Okay, hello everyone. How are you all doing today? This is our second webcast in the series on Informix tutorials. Anyway, welcome to our tutorial on configuring a new Informix server. I am Lester Knutsen with Advanced Data Tools, and I've been working with Informix since 1983, and we're going to dive right in. This WebEx is on configuring a new Informix server, and I'm going to give you some example scripts on how to configure a server. But what I really want to do is focus on the onconfig file and the settings you need to make in the onconfig file for CPU, memory, and disk. Next month, we'll have a webcast on disk configuration. And that will be a deep dive into how to configure disk and what works best for Informix and the onspaces command, and also using OAT to set up and manage your Informix database. So I'm going to start off with a quick demo here of a script to configure what I call a small Informix server. Then I'm going to go through CPU best practices, memory best practices, and then onconfig settings. And then we'll end with 10 scripts to configure a larger Informix server. So let me dive right in and show you my little set of scripts. To figure a basic Informix server, I usually have 4 files. The first file is an environment file that has the environment variables I need for that server. And this is a practice of mine. It's not a standard, but I usually have a variable called Informix chunks, which points to the directory where I want all the chunks to reside. And you'll see when I do the large server, it could point to several directories. Then I have the onconfig file. That's the second script here, and it's already ready to go. I have an SQL host file and then a setup shell script. And the setup shell script basically touches to create all the DB spaces I need. And then it does an oninit -IYVW to start up and initialize the Informix server. Then I look at any messages, and then it goes right into creating the DB spaces, creating the logs, and voila, it's done. I have a server ready to go. So let's just run it. And it's starting up the server. And this takes about a minute to run. Once it's finished running the server, it waits until some of the background processes have finished. And I'll share these scripts and the slides after we're all done on our website. Now I'm going in and creating the additional DB spaces. So I set up all the DB spaces. Now I'm adding the logical logs. And did a backup and I'm done. And so now if I do an onstat-d, you can see I have a server up and running. It's got 4, this is a small server, so it's got 4 DB spaces, and it's ready to go. So let's talk about some of the settings we used in the onconfig file. But before we do, I want to talk about CPU and memory and recommendations for setting up Informix. Now, with your CPU, let's define some terms first. The first thing is the chip or the socket. Back in the old days when I started, all you got was a chip. Now, chips have multiple cores on them, or multiple cores per socket. And every chip is different. The chips in the machine I'm using here, and let's do an onstat-g OSI, will show you the hardware information that Informix sees on your machine. It says I have 8 processors and all 8 are online, but that's not quite true. Because nowadays, most modern cores, and the 8 processors are sort of cores, but most modern cores are hyper-threaded, and they run multiple threads per core. And so when it says I have 8 processors, what it really means is I have 8 hyperthreads running. I know the physical layout of this machine is it's one socket with 4 cores, and each core is running 2 hyperthreads. The other factor in chips is the speed of chips. And I remember one of my first Sun servers, it was like a 90 gigahertz, actually megahertz, very slow compared to today's speeds. Now chips are super fast. So let's break this down a little bit. In this example, I have 2 physical sockets, 2 physical chips. Each chip has 5 cores, and each core has 2 hyperthreads. So I have 20 virtual cores. I have 10 cores, 5 on each chip, and 20 virtual cores, which includes all the hyperthreads. Now, this is the key. A virtual core can only run when there is free time. One core can only run one process. So even though I have 20 virtual cores, only 10 will be running at one time. This is a key thing to understand about hyperthreading. And the same with AIX and SMTP threads. Yes, there are virtual cores, but it still only runs one process at a time. And what happens is it's so fast that most of the time it will have to wait. And then when it's waiting, it will run the second hyperthread. So that's a key point to remember is if you have 10 cores, you're only going to run 10 things at a time. My system here with 8 processors, but it's only got 4 cores, it can really only run 4 things at one time. So how do you configure Informix? What you need to think about is how many cores, how many processors you want to allocate for Informix. What else is running on the machine? If the machine is a dedicated database server, the traditional best practice was the number of processes minus 1. So if you had 8, you would say, I could run 7 Oninit CPU cores on that machine. However, nowadays, the CPU cores are so fast that you can sometimes run 2 to 3 per core. So these are about 2 gigahertz. I could easily run 16 Oninits on this machine with 8 processes. Now, a key thing in monitoring this is to look at how busy your CPUs are. And a very simple way to do that is to do a vmstat 5.5. That will run vmstat, seeing how busy my CPUs are, and that's right over here. And it's going to tell me the lines wrap a little bit, but this 100 is this column ID, which says I'm idle 100% of the time. This machine is not busy at all. It's idle. It's not doing anything. My best practice is that you want to keep the busy to less than 30%. That is good performance. That way, when you have a workload spike, you have enough free processing power to handle that spike so that you don't stop everything. The way I like to think about it, once your CPU gets over 60 to 80%, you just don't have any extra room to add more processing thing. I was working with a registration system a while back, and they would have spikes every quarter when everybody wanted to register. The rest of the quarter, everything was quiet. And if they did not have 30 to 60% idle on average, they were not able to handle their spikes, because when their spikes happened, they would get 100% busy. And if they were 100% busy all the time, they would have not been able to handle that spike without everything slowing down. So you want to save about 60% of your CPU load to handle spikes, to handle flexible things. Say another example of a spike is the Christmas shopping season if you're in a retail industry. If you're in a payroll system, you may have certain days that are paydays, and those are going to be spikes. Now, for AIX, they, instead of hyperthreads, they call them SMTP threads. And here's an example of an AIX system. And it has 16 CPUs, it says, but really it only has 4. And this is a really good example, I think, because it shows you that every fourth one is busy. The others are basically not very busy. And that's because the others only run when there is a free SMTP thread to run. So the best practice if you run CPUs, and I want to say here the key is to test. Don't assume. I've been in a lot of places where they say, we bought hyperthreads, we bought 8 hyperthreads, we got to run all 8 threads. What I've found is on AIX, and IBM has a paper on this, on best practices for running databases on AIX. On Power 6 or 7, keep it down to 2 SMTP threads per core. On Power 8 or 9, about 4 SMTP threads per core is the best practice, not the full 8 that you could run on a Power 8 or Power 9. On Intel, I've benchmarked that it's better to turn off hyperthreading and run 2 Oninits per core instead of 2 hyperthreads and 1 Oninit per thread. And the reason to turn off hyperthreading is hyperthreading does take some CPU overhead. You turn it off, you've given the CPU more power to run your real stuff. And the Informix Oninits are multi-threaded. So an Oninit is going to start running, and it's going to have hundreds, thousands maybe of threads within it. And it's going to keep that one core busy. And therefore, there may not be enough to swap out and share resources with another hyperthread. So Informix has all these Oninits. If we look at the server we just started, and I do a PS minus EF, and I just do a grep for Oninit, I'll see all these Oninits that I've started up. All those Oninits have a different job to do. Some Oninits handle disk I/O, some Oninits handle users, some Oninits handle the work, and they're the key thing. When you do a PS, you'll see all the Oninits running. You can also do an onstat minus G SCH to see what those Oninits are. So if I do an onstat minus G SCH, I'll see that I have 10 Oninits, and the class tells me what they're doing. I have 2 CPU Oninits. I have 2 AIO Oninits. I have a couple of other Oninits, and let's look at what these Oninits are. So the CPU Oninit is the key one. This is what does all the work. And this is what you want to align carefully with the number of cores that you have on your system. The others all can run in the background, and they're very lightweight compared to the CPU Oninit. And in my example here, I've got 2 CPU Oninits. Now I have 4 cores and 8 processes, so I've got plenty of processing power to even run up to 4 to 16 CPU Oninits on this machine. Then you have an Oninit for the physical log, an Oninit for the logical log, and then AIO Oninits that handle disk IO. And these handle all access to the disk. And we'll talk about them in a little bit later, but they're critical to get your data written out to disk. We have a shared memory Oninit or a TLI or a socket Oninit to handle communications. You don't have to have all 3. In fact, you only will have a TLI one on Solaris. Most other operating systems use a socket Oninit to perform network communications. You'll have a FIFO Oninit for some input-output. You'll have a optical Oninit if you have an optical disk system. You'll always have an admin Oninit. You'll always have a miscellaneous Oninit. If you have auditing turned on, you'll have an auditing Oninit. And again, if we come back here and look, we have the logical log, we have the admin Oninit, the physical log, we have a miscellaneous one, we have the FIFO Oninit. Now, some of these Oninits are started automatically. You don't have to worry about them. The PIO, the LIO, the FIFO, the admin, and the miscellaneous are all started automatically. When you turn on auditing, the ADT Oninit will start. If you have UDRs that call Java or start a data blade, a user-defined Oninit may start up automatically. Again, those are only called when needed. So this first 5 here are started automatically. The rest are only called when needed. Now, in your onconfig file, you can configure the CPU and the AIO Oninits. And this is a key thing to think about. The CPU Oninit is what's going to handle your users and your session threads. Now, it's a multi-threaded system, so one CPU Oninit can handle hundreds of users, threads, but you want to spread the load out. So the more CPU Oninits you have, the better the load will be. Again, up to the number of cores you have in your system. So let's take a look at the parameter for doing this. And I'm going to bring it up here. If I do an onstat -c and grep or VP class, here is my line that says this is what I have in my onconfig file. Right now, I have 2 CPU VP class Oninits. Now, so here's some examples. For an 8-core machine, you might start up 4. You could also start up 8. You could start 8 and add the parameter to Affinity. And there are a couple of options for Affinity. Let's talk about this first parameter, no age. No age tells Informix to tell the operating system not to lower the priority of the process as it runs. All good Unix systems, and this is from day one Unix, lower the priority of a process the longer it runs. And this is why in the old days, before NoAge came around, you used to reboot your systems once a week. Because over time, the Oninits would get a lower priority from the operating system, and you need to reboot the system to bring it back, reset the priority. Nowadays, you can use the NoAge parameter, and almost every operating system supports that. And that just tells the operating system, don't lower the priority of this process. And here I have one with 4, one with 8 Oninits. The Affinity tells it to pin the processes to a particular core or CPU. And the way to think about it is Affinity 0 says, okay, start with the first core and pin one of these Oninits to each core. That means they cannot swap. Now, the advantage of not swapping is every time they swap between cores, all the information that it was using has to get moved to the other core, and there's a bit of overhead with that. By telling it to affinitize and not swap, and this is different from NoAge. NoAge means lower the priority. Affinitize means don't swap the CPU it's running on. I like to say it's like pegging a Oninit process to a CPU. It doesn't then have to move all the context every time it moves the process from one core to another. The problem is it can keep a core busy all the time when you do that. And I used to do this a lot with most modern operating systems. They're so fast, I rarely do that. The second example is saying only affinitize 1 to 4 and let the other 4, see I have 8 here. So I'm going to take the first 4 and pin them to particular processes, starting with process 1, not 0, which is actually a best practice. Leave 0 free for the operating system. Start your affinity at 1. And that way 1 to 4 will be pinned. The other 4 Oninits will now float and depend on which one is the most free. And so when something needs to run in one of those, it'll say, which one's free, and run on that. That's the advantage for floating. When you affinitize, you'll see a message in the online log saying, okay, I've taken this Oninit and I've tied it to this processor. I've taken this Oninit and tied it to this processor. 3 other settings in the Onconfig that are really important is multiprocessor. You always want to set it to 1. I'm actually surprised that's not the default because all machines today are multiprocessor. And that just tells Informix to use the multiprocessor code. Single CPU VP, you want to set that to 0 to allow you to run more than one Oninit. Now, if you're only going to run one Oninit, set this to 1. And it will actually optimize for running that one Oninit. And you also want to set NoAge, and almost every operating system supports it today. There's another parameter called VP memory cache. And it's a parameter. By default, it's blank, which means there is no cache. But that gives each Oninit a private memory cache where it can get memory from first before it has to go out to the global pool of memory. All of the Oninits share the global pool of memory that Informix has. Informix uses shared memory. This says Let's give each one of these Oninits a little bit of private cache that they can get stuff from first. And it's just a little bit faster for them to get it from that private cache. I typically like to set it to about 4K or 8K on most of my systems. Not too big, because you're taking memory away from the whole system. And if you make it too big, you reduce the amount of memory available to the whole system. You can also set it to be dynamic, or you can set it to be static. I tend to not do that and just set a size. Dynamic will means it can grow if needed be. When it grows, it doesn't give memory back is the only problem. So I like to have it set to a fixed size. Now, that's for your CPU VPs. Your AIO VPs also are set with the VP class. And there's a parameter called auto AIO VPs, which by default is set to 1. And I'll talk about the auto parameters in a little bit. But this means that Informix will add AIO VPs as needed. This can lead to the problem of too many AIO VPs running. I've worked on many systems when I do performance tune-ups, and one of them I was at a site, they had 256 AIO VPs running against an 8-disk system, and their system was just crawling. And it was crawling because they had too many things trying to write to the same disk. What I really recommend you do is think about this. Turn off auto AIO VPs. They had auto AIO VPs turned on. And think about how many VPs you want to have running per disk. You've got to test it. And there's another parameter. If you have KAIO turned on in the operating system, you only need 2. You don't need any more. If KAIO is off, which is the default, you never need more than 2 times the number of active chunks. This is my guidance on it. So you need to look at your system and say, how many active chunks do I have? Let's say you have 50 chunks, but at one time, only 12 of them are active. If that's the case, you never need more than 12 times 2 would be 24 AIO Oninits. The other thing to consider is most hard disks can only handle about 8 writing to a disk at once. So if you're on a 1 hard disk system, you don't want more than 8 AIO Oninits. Now, if you're on a big SAN, that doesn't matter. If you're on an SSD drive, that doesn't matter because they can handle many more AIO Oninits. But if you're limited to physical hard disk, you want to keep it to less than 8 per AIO Oninits. So here's some examples. I have 1 disk, 24 chunks. I'm going to set it to 8 because 1 disk, I want to keep it limited to 8. I have 6 disks and 24 chunks, and only 12 are active. So I'm going to set it to 12 times 2, which would be the 24. This is a parameter you put in your onconfig file. The third Oninit that is controlled in your onconfig file is NETTYPE. And NETTYPE is the communications network protocol that you will use to communicate between clients and the server. And there are 3 network protocols. There's shared memory, there's TLI, which is for Solaris, and SOC, which is basically for everything else. And so in your onconfig, you'll have a NETTYPE setting. And depending on whether you're on Solaris or Linux or AIX, you'll use either TLI or SOC. And then if you use shared memory, you'll use a shared memory setting. And what the NETTYPE setting does is it takes a protocol, that's this first field right here, and then it says the number of Oninits to run. That's the second field right here. So in this example, I'm saying for shared memory, I'm going to run one Oninit, and I'm going to expect 50 connections. Now, when I get the 51st connection, that's okay. It will expand dynamically. But I'm going to optimize for 50. And then the second line here is saying for networks using sockets, I'm going to run 4 Oninits, and each one is going to expect 250 connections. So this is going to be optimized for 1,000 users. And then you have the type of Oninit, whether it's going to be a net or a CPU. For shared memory, it's fine to use a CPU Oninit. For a network setting, always use a net type of Oninit. And let me give you some more examples here. So here's an example. I have one Oninit for 50 connections. And then I have 4 Oninits, each for 250, which is 1,000 network connections. Now, let's dive into memory and setting up the memory for your Informix box. First question to ask is how much is available? If you run onstat minus OSI, it will tell you how much Informix memory Informix sees and how much it sees as free memory. And that's a good starting point. And you got to think about what else is on that machine. Are you going to run more than one Informix server on that machine? Are you going to run 4GL apps? Are you going to run a web server? And you need to think about how much memory you want to assign to Informix versus everything else. You don't want to assign too much memory or the machine will slow down and swap. One of the exercises we do in the advanced class I teach is we'll slowly increase the memory for Informix. Run a benchmark. Increase the memory again. Run a benchmark. The benchmark runs faster. Increase the memory again. Run the benchmark again. It's faster. Everybody gets really excited. We're making everything run faster. And then suddenly you'll make it too big and the machine will crawl. Oftentimes I have to hard reboot the machine at that point because it's swapping out to disks so bad that nothing can run. And that's the danger. You always want to make sure you have some free memory. You don't want to have swapping. Now, Informix uses 4 types of memory. There's the resident memory. There's a buffer pool memory segment. There's virtual memory, which I like to call working storage. And then there's message memory. So the resident memory, and this is all shared memory. All the Oninits share this memory. It's not like each Oninit gets this much memory individually. The first Oninit goes out and allocates this memory from the operating system. And then after that, all the other Oninits attach to that same memory. So the resident memory segment is where the control tables are for your configuration. And on older systems, that can be where the buffers are. The buffers can also be in a separate shared memory segment. The virtual memory is where your working is. And that's where things like dictionary caches are. I see there are a couple of questions, and I'll get that to those in just a little bit if you can hold on to that. But please put your questions in the chat and I'll come back to them. So the virtual memory is your working memory. And that's each user is going to get a portion of that virtual memory for their SQL, their dictionaries, for the tables they're reading. If they do a sort memory, it's going to be in that virtual memory. The message memory is a very small memory segment, and I usually say don't worry about that. That's basically a buffer between the client and the server. So you have data that needs to go back to the client. It gets put in the message memory segment. And from there, it goes back to the client. So what you really need to worry about are the buffers and the virtual memory segment. So I will, Ernest asked a real good question here, and I am going to answer that because it does appropriate that. Should you turn off swapping? That is a hard thing to do because if you turn off swapping, you may actually lock up if it runs out of memory, and the whole machine may lock up. So I would not turn off swapping. I would monitor it though to make sure I don't run out of memory. And if I go back here to my VM-stat, and I'm just going to do VM-stat 5-5. See this column here called swap? The swap outs should always be 0. If you run VM-stat 5-5 and you see numbers here, particularly in the SO, that means you're swapping. And that means you need to go look at what's taking up all the memory. And if you turn off swapping, that means the machine's going to freeze because it doesn't have any more physical memory to operate. And with swapping turned off, the whole thing will just freeze. So Ernest, I hope that answers your question there. Good question. Thank you. So let's dive in a little bit. And I want to talk about how the memory gets used because this is a very important part of Informix. The buffers, every time you ask for data from disk, it gets read into the buffers. And if you ask for one character, you do a select for a status field that's one character, it's still going to read a whole page and put that whole page in the buffers. And that way, if anybody else needs that data, it's already in the buffers. They don't have to read it from disk. And that's why you want to see something like a 99% buffer cache rate. That's a good sign that your data is in buffers. When all the buffers are full, the LRU queues kick in. LRU queues are least recently used queues. And so all your buffers are divided up into LRU queues. And the LRU queues monitor the buffers and say, okay, which is the least recently used page? I can kick it out and free it up for another page to come in. And so if that page has not been modified, it gets tossed aside and the next page comes in and so on. And that's how you get buffer turnover. Now, what happens when you start doing updates? When you start doing updates, those pages are marked as dirty and they have to be written out to disk before they can be discarded. And so the LRU queues also manage sending this data to the Oninit responsible for writing out to disk. And they go through some cleaners and they go through and then out to the Oninit to get written out to disk. The LRU queues wake up based on a parameter called LRU max dirty and LRU min dirty. And LRU max dirty and min dirty say what percent of my buffers can be dirty before I start writing out to disk. And then the min dirty is what percent do I stop writing out to disk. The default is 60 and 50. Start writing out to disk when 60% of them are dirty. Stop when it gets down to 50. And that's well and good for a small system. For a big system, let's say you have 100 gigs of buffers, and 50% would be 50 gigs. 50 gigs writing out to disk is a long time. That's going to be a bottleneck. And that's why a good practice, particularly on an OLTP system, is to lower your LRU max and min dirty so that you're writing out to disk more often in the background. If you're not writing out fast enough and all your buffers become dirty, Informix has to stop everything. All activity is blocked until it's performed what's called a foreground write and written data out to disk. And that is very expensive, and you don't want to do foreground writes. That's why you want to keep your writes down. The LRU writes are background writes. I like to call them lazy writes. They're not. They're not. They don't block anything, and that's why they may not be fast enough to keep up. But you want to have enough LRU writes so that most of your data is written out in the background. Now, when a page is written out to disk, it's marked as clean, and it can then be discarded and reused if need be. Now, when you have a checkpoint takes all your dirty buffers and writes them out to disk. And when a checkpoint is done, all the buffers are clean, and this whole cycle starts over again. So this cycle happens very fast. If your checkpoints are every 5 minutes, you're going through this cycle every 5 minutes. Now, to monitor your memory, you want to do an onstat minus G SEG. And I'll do it right here. First thing to look at is this number right here is the total amount of memory that Informix is using in KB. And then you have the different class segments. And we have the size of each of those segments. So R is resident, V is virtual, B is the buffers, and M is the message segment. The message segment you never worry about. And the resident segment is fixed when you start up Informix. What you want to do is worry about the buffers and the virtual segment in terms of monitoring that. So I'm using about 1.3 gigs on this system. And if you remember right back up here, I have about 16 gigs on this system. I'm barely using any memory. The Onconfig settings that affect memory are buffer pool, shared memory virtual size, and shared memory add and locks. Now, number one best practice, the more buffers, the faster your database will perform. If you have enough memory that you can put your whole database in memory, that will be great. And Informix can perform as a memory resident database. I was working with a system. Their database was about 250 gigs. They had 512 gigs of memory. We made the buffers 250 gigs. Their whole database fit in memory. It was super fast. The goal is to avoid buffer turnover. Buffer turnover is when you have to continually read pages in and out of memory. And Art Kegel, a good colleague of ours, has a rule that if you have a buffer turnover ratio of more than 8 times an hour, that's going to affect the performance of your memory. And I have seen this. I've tested this. I've done performance reviews with clients, and we'll go in there and say, one worst case was they had 300 times an hour. That means 300 times an hour, all their buffers were getting trashed. That's about 5 times a minute. All of their buffers were getting trashed. We slowly brought that down over time by increasing the size of buffers. And every time we did it, the next week we would do it. We doubled the buffers and tripled the buffers and so on, and we did it, over a 2 month period, so that we could monitor it. And every time we did it, the next Monday, everything was faster. And then we did it the next weekend. It was so much faster. This is the number one thing you can do to increase your performance, is to make your buffers big enough to avoid any swapping. Now, if you make them too big, then you'll get swapping. Now, in the onconfig file, you'll have 2 lines for buffers. You'll always have a default line. Leave the default line there. It's very important. If you take that default line out, Informix may not be able to add the DB spaces because it uses that default for adding DB spaces. Don't change the default. Then you'll have a line that says buffer pool, and it'll give you a size in pages of that buffer pool. And this is the size you want to change. In our onconfig for the server we just created, I have a default line. I'm not touching that. And then I have a buffer pool size 2K, 500,000. And that's 500,000 2K pages. So I'm setting up 1 gig. It's 2 times 500,000 equals 1 gig of memory for buffers on this small server. And I've worked with systems that have set up to about 0.5 terabyte. If you have 1 terabyte of memory and you can afford to put 0.5 terabyte for buffers, that is great. There's a good question from Raj. I'm going to answer it about this. In previous versions, you're right, the buffer pool did reside inside the resident version. That has changed, and now it's a separate memory segment. And when you set this parameter, it's affecting that separate memory segment. That is correct. And here's some examples. If you have 3 gig of memory for buffers on a 2K system, I'm saying 2 times 1.5 million pages or buffers, that equals 3 gigs. On an AIX system with a 4K page size, and if I want 12 gigs of memory for buffers, I'd use 300,000 here. I'm sorry, 3 million pages, because 3 million times 4 is going to give me 12 gigs. And on a Solaris system with a lot of memory, I might use 48 gigs, which will be 24 million pages. If you have 2 buffer pools, and you can do this, this is an example where I have a 4K and a 16K buffer pool. You have to have 2 separate entries, and you can set different page sizes for each of those buffer pools. A couple of other tuning things. By default, auto LRU tuning is turned on. And this means that Informix is automatically going to I see your question, Raj. I'll get to it in just a minute. So Informix is automatically going to do the LRU tuning. That means it's going to ignore what you put in here for the LRU min and max. That's not a best practice. And I typically, particularly on OLTP systems, find that the best practice is to turn off auto LRU tuning and set the LRU min and max to very low values. So the system is continually writing data out to disk in the background. Now, Raj asked another question. In the current version, resident memory values from OnStat. That's a hard one, and the best way to figure it out is to do an OnStat minus G SEG, like you said. There's not a parameter that you and I can use to control that. So to me, that's how much Informix needs for the control tables on your system. And that's fixed when you start up. We'll start a large server in just a minute, and you'll see it'll probably be the same as it on this system. It's just a fixed amount. On stat minus G, SEG will tell you what it is. There's nothing you can do about it, so there's nothing to tune here. The ones you tune are the virtual and the buffers. So I hope that answers your question, Raj. So if you have a turnkey or an embedded system, auto LRU tuning is fine. If you have a high performance OLTP system, you want to turn auto LRU tuning off and set your LRU queues. And the LRU max and min is what percent to start cleaning, what percent to stop cleaning. And you can do this at 1 and 0.5. 1 means if you have 1% of the buffers dirty, start cleaning, and 0.5, stop cleaning. Typically, I'll do it at 10 and 5 or 5 and 1 so that it is keeping them fairly clean. Shared memory virtual size. This is the second segment of memory you can control. This is this V right here. That's the shared memory virtual size. And this is the workspace. It will grow. If Informix needs memory, it will go out and get more. And so the best practice is to monitor it and set it large enough so it doesn't need to grow. Because every time it grows, you've now got fragmented memory. And the process of stopping everything to add memory that Informix has to do will slow down Informix. And now you have 2 fragments of memory. That can slow down things. So the best practice is if you see additional V segments, the next time you reboot your server, add these numbers up and make the initial size big enough so you don't have to grow. So this looks like I've added 16 gigs of memory. So what I would do is add 16 gigs to the 32 gigs I already have so that the next time I start up the server, it's going to have 48 gigs of memory here and not need to grow. Now, 2 is not too bad. What's really bad is when you see 30 or 40 here. And I've been to sites where I've seen hundreds of these virtual segments. That's really bad. Because Informix will go get that memory, it may need it for one particular job, and then that memory stays there. And Informix continues to reuse it, but it's then very fragmented. So a couple of other memory settings. One is resident, and you've got to be careful with this one. The default is off, but resident says do not swap. And this is the question, the other side of Ernest, your question. This is how you tell Informix not to swap memory. And if you say resident equal 1, it will lock the resident segment. You can say resident and you can give it a number, and then it will lock the resident segment and the next set of virtual segments. And if you say -1, it will lock all memory. Now, -1 is like turning off swapping. I would do that when I'm very confident that I'm not going to have an out-of-memory crisis on the machine. I typically, on this example, I typically would say, let's go set it for the first 4 segments. And on most systems, I would set resident to 4 so that the first 4 segments get locked in memory and not swapped out. Then if Informix does need to add memory, it can add it, and that additional memory can get swapped out if it needs to. Again, best practice is to monitor so you don't have swapping. Shared memory add is the size in KB of how much memory to add if you need to add memory. Now, a key thing is locks. Locks are, next to buffers and virtual memory, one of the most important memory structures in Informix. Every time you open a database, every user has to get a lock to make sure no one drops that database. Every time you open a table, you have to get a shared lock on that table. Every time you open a row, you're going to get a lock on that row plus a lock on every index. So it's very easy for one person to get hundreds of thousands of locks. And the default locks setting in a server is 20,000, which can be very small. And Informix will automatically, dynamically add locks as needed. The problem is adding locks dynamically will cause a performance slowdown. Here's an example. On stat-k, look at the last line. And this says, I've used 80,000 locks, and I've overflowed the lock table 2 times. So what I should do in this example is go set my locks to 80,000 in the onconfig file. Restart the server. You can't set this dynamically. And then away you go. If you see, when we do our benchmarking class, we'll often see this go up to 5 or 6 overflows and 600,000, a million sometimes. Setting this will take memory, and but it's I think one of the best uses of memory, because having one lock table in memory is one easy place to go search. And everybody, before they open any record index, will have to go look in the lock table to see if that's locked. So this is the most active structure in memory, is the lock table. And having it big enough so that you don't overflow it is a key setting. So avoid overflows. When the lock table overflows, it often causes your virtual memory to grow, because it says, okay, I need to overflow, I need more memory, go to the virtual memory. Virtual memory is full, so then it has to overflow and get more memory. So set your lock to a value that will not overflow. So that's my basics on memory and CPU for the onconfig. Let's just take a look at a couple of other things. My minimum to set up an Informix server are these values: the root DB space, the message path, the console, the LTAPE device. And I'm going to go through this really quick because I want to get to my last demo. So you've got to set your root size. And typically, don't go with the defaults. You want it at 2 gigs or something bigger than that. You need to set a message path. And I like to include the server name in the message path. So that is very easy, especially on a machine when you have multiple servers, you know which message path you're looking at. You want to set some backup. If you're using OnTape, you want to set LTAPE dev. And I have a future webcast on backups where I'll talk about this more. You have to set a server number, a server name, and a server alias. The The server number must be unique for each instance on a machine. If you're going to run 12 Informix instances, you need 12 unique numbers here. This is actually used as a starting address in calculating where shared memory will go for that server. And then you have the server name and the alias. You want to have your NETTYPE settings. And the rest of this is sort of a review of the Onconfig file. I'm going to skip it. Let me just see if there's anything I haven't mentioned. We're out of time here. And I want to give you my last demo. So when I'm setting up a new server, typically they're medium to large servers. I use 10 scripts. I like to break it down into 10 separate steps for creating an Informix server. The first script sets up the root DB space. Second script actually initializes the server in the root DB space. The next script makes a physical log and moves the physical log to a separate DB space. Then I like to set up 2 DB spaces for logical logs. And then I create the logical logs in these 2 DB spaces, alternating between them. And the idea here is when I'm reading and writing to one logical log, the other logical log that's being backed up is in a separate DB space. So I'm not conflicting between the backup of the logical log and the writing to the current logical log. Then I like to have a script that creates my temp spaces. Then I think one thing that's very important in version 11 and 12 is to move the sysadmin database out of the root DB space into its own DB space, because this database can grow over time and you want to give it some space to grow. And then I have a script to set up a bunch of DB spaces for data, a script to set up DB spaces for indexes. And then the last thing I do is I want to turn on, particularly with cooked, you can't do this with raw, but with cooked files, I want to make my chunks expandable automatically so they never fill up. Now, they will still fill up when I run out of disk space, but let's say I have a terabyte of disk and Informix is using half of that. By setting them up to expandable, when a DB space fills up, Informix will automatically extend that DB space. Then I usually have a script to clean up and start all over, and then a script for the Informix environment and the server settings. So let me show you how this works. And so I have a directory here with the 10 scripts in it. And I'm just going to look at each one real quick. The first one, on a big system, I don't want to put everything in one file system. So here I'm going to make 6 different file systems. Now, I've already made them on the Unix side. So here I'm creating directories that I'm going to put everything in. And then I'm going to have one directory for links so that after I'm up and running, I can move things around if need be between file systems just by moving the links around. Now, every time you use a cooked file, you've got to change the permissions to be 770 and make sure that the owner is Informix and the root Informix. So let's run this. So now I should have in Informix chunks a directory called new server 2, and I have my 6 directories for all my DB spaces and a directory for all my links. And the links will point to the actual DB spaces in there. Now the second one I would run now is actually going to initialize the server. And all it does is it copies the onconfig, copies the SQL host file, does an oninit and an onstat. So let's run that. This is starting up the instance. I made some of these sizes smaller than I do. Oftentimes, this is going to be a 2 gig root DB space. I'll often make it 4 or 8 gigs, depending on the client. So now I've got my server running. I've got one pointing out to the root DB space. And let's look at 3, which is making the physical log. This is very simple. I'm going to touch the physical log. I'm going to change the permissions. I'm going to link it. And then I'm going to do an onspace -c -p. The -p tells it to, in one command, move the physical log from the root DB space and put it in here. And it's going to make it as big as the size I give it. Here I'm making the physical log 4 gigs. And you know, I think best practice is the physical log should be 1.5 times the amount of memory you're going to give Informix. So if I was going to give Informix 2 gigs of memory, the buffers, I'd easily make this 3 gigs. So let's run this. It verifies the and see it's creating and moving the physical log to the new DB space. Now if I do an onstat -d, it's used that whole, remember this is in pages, so that is 4 gigs, which is 2 million pages. And there's no free space. It's used all the space up for my physical log. So let's make the logical logs. And here I'm going to create 2 logical log DB spaces. This is a very simple script. And now I've got, but they're empty. So I've created 2 DB spaces, but they're empty. What I have to do now is move them. And to move them, I have to do I call it a little song and dance. I'm going to fill them up with 196 logical logs. I'll talk about this in one of the future webcasts when we talk about logs. But the best practice is you want enough logs that you can have 3 or 4 days of logs. And what I'm going to do is I'm going to create 6 logs. Then I'm going to move the current ones in the root DB space to one of the new ones. So I'm going to do an on mode -6 because I have 6 in there right now. And then I can drop the first 6 logs, which are in the root DB space. And then I'm going to do a while loop where I'm going to add 1 log and I'm going to alternate between the 2 DB spaces 95 times. And so this is going to create 1 in one DB space, 1 in the other. That way I'll alternate between the 2. Let's see how it works. So there's my first 6. Now it's going to go about dropping them. And now I'm going to add the rest of them. While that's running, let me look at your questions here. So good question, Ernest. You don't. If you have resident set and you have the other parameter on the CPU VP, you don't have to bounce it unless you have a memory leak. And the memory leak could be because of the version of Informix. It could be for a number of reasons, but I rarely bounce servers. In fact, uh, I make I make it a big thing of keeping servers running. We've had servers run for years uh, that Informix will just do that. Now somebody asked, good question, Raj. Uh, if you create the physical log using the command I did earlier, it will auto extend it. I want to show you something. You see this E right here. This E behind the physical log means it will auto extend it if the physical log is too small. And we're going to make all of our chunks auto extendable in just a little bit. But that will make it expanded. Somebody asked to see a ls minus L on the links. And that's what the Informix links directory does. I have my links going out to the different DB spaces. I'll show you this at the end because it will look pretty busy then. So now I've got my logs on stat-L. You can see I've got my 196 logs out there. Let's see what's next is 7. This is moving the sysadmin database. And there are two parts to this command. The first part is creating a DB space for that sysadmin database. And the second part is actually moving it. And you can ignore this message here because while it was moving it, it had to shut down the sysadmin database, and that's what gives that message. This is the command to move it. And I'm moving it to a DB space I called sysadmin DBS. And if I do my onstat minus D, you can see I've got my sysadmin DB space here. And it's right there. Let's make this bigger. Okay, so now we're at 8. And 8's going to take a few minutes because what I'm going to, let me show you what 8 is. 8, I'm going to create one data DBS, and then I'm going to create 12 additional DBSs for partitioning. This is just typically what I'll do when I'm planning a system. I'll work with a client and say, let's create one DB space for your main databases, and then let's create a bunch of others. And this uses 12 because I want to partition things by month. And that way I'll have one for each month. I could have made 4 and put 3 months in each DB space. That's okay. But I just use this as an example. So I'm going to create one DB space for data, the basic database, and then I'm going to create a bunch of partition DB spaces out here. I'm not going to do any partitioning yet. That's for a later presentation. So it's just going to sit here and create a bunch of DB spaces. Now, I'm not sure I understand your question, Ernest. Causes segmentation fault, adding auto adding shared memory or logical logs. Segment faults are caused by a number of things. And 3 different questions. And without knowing the details, it's hard to say them. auto adding shared memory is fine. You don't auto add logs. So the segment fault basically says, you know, I need this memory segment and I can't get it. It's not there. And there are multiple factors of it. There's segment faults, which are not serious, or others which will cause a core dump. So segment fault is a very broad term to use here for what causes it, because there are millions of things that can cause segment faults. You got to look at, okay, is there a problem here that I'm having? In the online log, you see adding shared memory. That's because your shared memory is full, your virtual memory is full, and Informix needs more virtual memory, so it will automatically add it. That's what you're seeing in the online log when you see it adding shared memory. So all the if you do the onstat minus G SEG, all this virtual memory is full. Right now we've got plenty free, but if you had done that and this said 0 right here, that means it needs to add more virtual memory. And if you do that and there's no more physical memory, yes, it will cause the OS to swap out. So hang on just a minute, you guys. Let me finish this example and then I'll get to questions. On stat minus D, now I've got all my DB spaces. If I do a LS on the links, you see I've got my links all to the different file systems that I have this database spread out on. One more to do is to make the index DB spaces, and I'm going to create 4 DB spaces here for indexes. Depending on the system, I may do more, I may do less, depending on how much data I want to load. The key, I think, when you're creating indexes is I'm using a 16K page size. So now, because it's created a 16K page size, if I do an onstat minus G SEG, I have added a second buffer pool here. That's this buffer pool right here for the indexes. And that's one of the reasons I like doing this. Indexes perform best in 16K pages, and having them in a separate buffer pool means you can tune one buffer pool for data, one for indexes. And then the last one I want to show you is to make all these extendable. And what I'm going to do, this is a sysmaster script. I'm going to not remove it at the end so I can show you what the script looks like. This is using SQL to write SQL. I'm going to create a SQL script here by reading from the sysmaster database. And I'm going to say, create the script that is going to execute this function. And I have to give it a chunk number. I can't give it a chunk name. So I'm saying, get me the chunk numbers from everything except for, I don't want to make the root expandable. I could. I don't want to make the physical because it already is. I don't want to make the logs, and I don't want to make the temps expandable. I could. It wouldn't hurt doing that, but I'm saying don't do those. So this is going to go through all my the sysmaster database through sys chunks, and it's going to get the chunk number of all my DB spaces except for these. And so, whoops, I want to leave that script, that I want to comment this out so I can show you the script that runs. Now it's going through and it's marking each of those as expandable. So now if I do an onstat minus E, I see an E here by the chunk. And that means if that chunk fills up, it will automatically expand as long as there is disk space in that file system. And it's a very simple script that I just generated. You have to give it the chunk number. And that's what my sysmaster query does, is it goes out and gets that chunk number there. Should you automatically add logical logs? Yes, you can do that. I actually recommend planning ahead of time and making sure you have enough logs that you don't need to automatically add them. Copy of my scripts. My plan right now is probably Monday or Tuesday, we'll have the webcast up, we'll have the PDF up, and I'll have a zip file with all of my scripts in it so you can grab them. How many times dynamically increase the logs? Because blah, 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 blah. It will keep increasing them as long as you have memory. And it will stop when you run out of memory, yes. Now, if you're in work group, you actually have the work group limit for memory. And once you run out of memory for locks, that is really bad because if you don't have enough memory for locks, the server can't function. That's going to freeze up everything. So not only will you run out of memory, but you will freeze up the server. So good questions, you guys. Let me finish a couple of things here, and then I'll come back to see if there are any more questions. I want to point out, the Informix user group, you guys are all members of it. The key new thing I have really enjoyed lately is the Informix community. This is an IBM hosted mailing list that you can sign up for. And it replaced the old Informix list. And this is the best thing around there. It is, I've missed the Informix list. I can't tell you how much I've missed it. And this is the first thing I read every morning in all my emails. I get continual emails from it. And if I click on that link, you'll have that link in the slides. It takes me here. You have to get an Informix ID to get to it. But then you have all kinds of good stuff from users, and you can set it up to send you emails. Right now, there are 247 members. I hope it grows. I wish there was a way to get it out to everybody who is on the old Informix list about this, because this is the best thing around. And again, the iiug.org/community is the way you get to it. It's IBM helping out the Informix community here. Our next webcast is March 19th. I'm going to talk about disk space. And I'll talk about SSD drives and SANs and RAID and all that kind of fun stuff and what you need to do to set up the disk space in more detail. Then April 30th, we'll talk about logs. And then in May, we'll do backup and recovery. And then in June, we'll talk about connecting users. This is really about networking. July, we'll talk about creating tables and databases and a little bit about partitioning your tables here. And then in August, we'll wrap up this series of free tutorials on monitoring the server. Now, these are just a basic. We do have classes, and I have one coming up in May for Informix for database administrators. If you're upgrading to 14, I'd highly recommend it. The first thing we will do in that class is an upgrade. We'll start the class on Monday on version 12, and the first thing we'll do is upgrade that to version 14. And I'm using the latest version of 14. If I do an onstat dash, you can see where I'm on 14 FC3 now. If FC4 is out, we'll use it for this class. Then in July, we have an advanced performance tuning class that Art and I are going to be teaching. This is a benchmark class. If you know Informix really well, the class for you, because we're going to talk about all the advanced performance tuning things we need. And then in October, we'll do another Informix class. And this is our training room. We have 8 servers. I have room for 4 people to come here and sit in our training room, and then 4 servers in our server room. Each student gets your own server. Now, I can teach a class with 8 people remote. That's easy. It's all by WebEx and SSH into the server. And so with that, I know I've gone way overboard here on time. Good question, Raj. You need an IBM login to get to that. So if you go to the IIUG website and click on it, and then you need to go to get an IBM login because that's IBM is hosting the website. So your IIUG doesn't work. Go to that link in the slides and click on it and then create, if you don't have it, an IBM login. Cool. Well, I am way over time. Thank you guys for being patient and staying with me on this. I really appreciate it. And we will see everybody at the next one where we'll talk about SSD drives, SANs, and RAID. And what's the best way of getting the best Informix performance on your disk drives. Thank you all and have a good day.